Varjo is a company we were founded 5 years ago. We're based out of Finland, and we focus with the office in the US in Washington. We are building VR and AR headsets which are focused on enterprise use, and we are active in more than 40 countries. So we just launched a new generation of headsets. They're called VR3 and XR3, and you can see them here on the screen. Both of them are built on our new display technology, which is extremely high resolution that matches basically the resolution of your eyes. So you can see everything in super sharp fidelity. And with the XR3 on the picture here, you can see that it has cameras in the front that allows you to do video pass-through technology. So that creates unique mixed reality experiences with photorealistic qualities that we will show you later. And next slide. And so what we're going to do here today is to talk about how collaborative mixed reality can change the shape of design from concept to sales, and what companies are doing to revolutionize their work in mixed reality. Then we'll talk about some key benefits using photorealistic mixed reality for design, and then we'll have a Q&A with us. So next screen, I'll leave it over to you, Anna.
Super, thank you. We at Varjo, we are actively speaking with our customers and learning about their ways of using mixed reality in their day-to-day work. And design and development and the creative process as a whole are areas where we today are seeing more and more companies and our customers worldwide to take mixed reality into use, and where we are seeing new ways of working emerge with the help of mixed reality. In this session, together with Marcus, we want to share some of the learnings we've made while working directly with our customers. And while these are industry-specific use cases and examples, we believe this will be useful for a wider audience, and that many of you listening today would find this interesting also in your own context and industry. The steps we are going to talk about are product design and development, design reviews and concept testing, and marketing and sales. So now let's look at this a bit in more detail.
Yeah, so in the first one here, which we're talking about the future vision of how we think people can work in mixed reality. And what you see here is a shot from inside our headquarters. It's shot from inside our XR1 headsets, which has the cameras on the front, and it picks up the real world and showing the virtual objects on top of the real world in this. So you can see that Janne here, who's running this, he's using a big display so he can see his 2D interface. So using his 2D interface, in this case Unity, he can use a 3D editor to rearrange things inside the office. And actually what he sees is the application of his virtual model on top of the real world. So here you see a perfect blend of the real and virtual objects. And what's unique here is that the high resolution of our headset is that enables you to see read the text on your essential 2D interface. So it could be, you could use this on any 3D modeling tool, like in this case we're using Unity, but it could be used in any tool, and you can see it instantly. So you can see the real world in blending with this. So it's pretty cool. So Anna, do you want to take the next one?
Sure. All right, this is an interesting video, and it has been shot at Varjo premises. We here have an example of mixed reality with two different objects shown for comparison. I would like you to place a close look at these silver spheres on the table. One of them is virtual and one of them is real. They look pretty much the same, and I would engage you to guess which one actually is which. It took me a while to figure that out. What this video demonstrates is how the virtual objects can react to changes in the environment. What's amazing about this video is that it is all happening in real time. So this is shot from our headset, and it has not been edited afterwards. The headset has cameras in front that point forward, and they are scanning the room around. And that scan would then be reflected on these virtual objects. Now, I would like you to look closely at the two objects on the table. When the light source moves, you can see that the spheres react to the changes in environmental lighting. The reflections on the surfaces change, and the shadows they cast move as well. This is, of course, a natural behavior for shiny objects in real life, And now we are showing how this is possible also to achieve real time, also with virtual objects. And about the sphere, I can see some discussion happening in the chat. So many of you guessed it right. The right one is the virtual one, and the left one is.
Good guesses. Great. So next one. So many of our customers that we work with, they really, it is really essential for them to bring down costs, and using mixed reality is a way to cut costs. And we work really, and like I think Lucas Fath here, who gave this quote, is putting it quite well. Lucas is the product manager for Autodesk's design software VRARA, and he puts it quite well when he says that the digital like mistakes done in the digital evaluation phase can become multi-million-dollar problems later down the road. And that's why it's essential that you have really crisp tools and instruments for doing the final design reviews. And it's this combination of VRARA's rendering capacity together with our resolution of our headset that opens up whole new opportunities to do this and cut costs. So we'll look at one showcase here on the next slide where we work together with Autodesk together with if you switch that, yeah. So together with Kia. So Kia is the car company. They're headquartered in South Korea, and using the VRARA tool and a remote collaboration setting, they're now able to do the world's first photorealistic mixed reality design review. And you can see that the car here is in full fidelity, and you're able to kind of do design decisions. And you can see other cars, the real cars in the background in the design studio, which this is shot in Frankfurt on their design studio there. And the people joining into this session here as avatars in the shape of Darth Vader in this case, that was the choice of Kia. They're actually dialing in from their headquarters in South Korea so that they can work remotely. And of course, in this year and past year has been really useful in doing this remote collaboration sessions. And you can actually see in the brown car in the background is one of the clay models that they use also for doing shape and designs. And that's now something that you don't need anymore. And it costs a lot, cuts a lot of costs. Next slide. And in this study we did cut down 99% of the review time. Like if you think about doing the reviews with the clay model, this is a lot faster. And I think we could think of this beyond. I mean, obviously automotive design is very innovative with its science, but it's not limited to the automotive industry. This is a huge opportunity for anyone working with any industrial enterprise designs. Like you could consider a watchmaker, for example, seeing all the intricate, and you can make the size bigger and smaller and go into to see the very details of it. Or you could consider shoes or heat exchangers or anything basically for helping cutting the cost in the design process. So Anna, do you want to take the next one?
Sure. As a designer researcher myself, I find this example particularly interesting. When it comes to testing designs and reviewing designs, it can easily sometimes be a matter of opinion against another opinion. And in this situation, it's really important to find ways to go beyond comments and find ways to use data for decision making. Is the design good enough? And does it perform right when it is put into test with actual users? This video shows an eye tracker at work. When testing the design with users, you will, of course, listen to their comments and see their reactions, but the eye tracker allows you to also know what draws their attention. We can keep track of what objects they exactly were looking at, collect heat maps to understand which contents they spend most time looking at, and find maybe there are parts that they missed out completely. And when this is done in human eye resolution, these participants can actually read the labels and see the price tags. And all this at the same time while they are free to walk around, discuss with you and other people in the same room, and experience the space in a realistic scale. This example here is from a retail space, but similarly eye tracking can be used for testing also products such as packaging design or labels, and also usability testing of a system or a human-machine interface is a good example where eye tracker can bring richer details and analytics than just a traditional qualitative usability testing would typically reveal.
Great. And so now looking at the last of the three vertical steps in the process, this is the sales process where we showcase an architecture case here where you can look at the flat and look at the house here. And we've shot this with a green screen technology. So it's inside the headset, you see the virtual world, but also in a chroma key room, you can also see the real person. So you could stand and have contact with the salesperson in this case, so that the salesperson actually appears as a normal person inside the experience. And this could also be done virtually, but like remote participation would be possible, so that you don't have to travel to your customer, of course. But essentially, it frees you from the physical restrictions of the physical space. And this could not just be a house that which is very difficult to move, of course, but it could also be an excavator, very heavy industrial equipment. We see a lot of customers that wants to do a run through of their new products, and they might just exist in tens of them or so, and you can't move them to the trade show. So in this case, you can do a run through of and see every detail of the object that you're selling in. This could also be used for configurators, so changing colors, changing various different shapes. And you could cut down the cost of a showroom, for example. We've worked with Polestar, the car brand of their electrical vehicles. So it's enough for them to have one small showcase pop-up store in the center, and then bring in the virtual configurations to showcase different colors. And you can really see the metal flakes of the paint coat of the car, and see all the seams of the leather and everything with our headset. So huge opportunities here. So next one.
I hope you found these interesting examples. And in these examples, we've shown you how you could increase productivity in creative design with 3D tools and real-time mixed reality. You can speed up the design process by bringing your design teams together, saving in time and costs for travel. I guess that's especially important now with these exceptional times. You can test the design concepts with end users in real scale and extend your observations from the data from eye tracker. And you can showcase your products free from the constraints of the physical world. You can carry your full product catalog with you and allow your customers to try out your products in the highest detail. I think now it is time to take some questions. Me and Markus will be staying around for a short while to chat with you and answer any questions you might have. I can see quite many questions already in the chat, so maybe we can start picking from some of them. But keep them coming, and the chat window is available for you to throw in the questions. Also, if you're interested, feel free to scan these web sources for more information about Varjo and our products.
Yeah, and I can see that there was a question about tethered. We are a tethered headset, so you would need to have a PC to run our headset. That's also needed for our render capacity and the low latency of our mixed reality headset. So
yeah,
there is a partnership program. Yeah, good that you asked, David. We do have a partnership program for software partners where we offer, like for those creating experiences that runs on our headset, we give out free developer kits to some extent. So go into our webpage and apply to the software program, or if you have any partners that are developing software, go in and check that out. I can send the link here. I'll have it here right in a second. There you got the link to the pricing. Anna, do you want to run through the pricing?
Sure. We are right now selling 2 products where XR3 is the flagship mixed reality device, and that starts from 5,500 euros in US dollars and goes with a subscription starting for 1 year at $1,500 US dollars. The VR3, which is a virtual reality headset for VR content only, starts at 3,200 euros. And similarly with a 1-year subscription of 800 euros.
And then we have a question from Kevin Kim. He asks about the highest resolution for, so when it comes to 3D 360 video in 3D video, I think we haven't really tried that, but 8K is definitely like we are beyond 8K when it comes to 360 videos. So what we are measuring it with pixel per degree, where HP Reverb has a pixel per degree, which is about 20 or 18 or 19, and our headset has 70 pixels per degree. So it's quite a lot higher than the existing consumer headsets.
I can take the question about the eye tracker. There is a question about what accuracy are you able to achieve with your eye tracking system, and assuming it is IR camera based. So that is correct. It is based on infrared cameras following the movement of your eyes, and we are talking about sub-degree accuracy, which means that when the field of view is measured in degrees, we are talking about less than 1 degree granularity in the accuracy. And somebody has said to me that what does this 1 degree mean? It would mean that if you put your finger in front of you in 1 meter distance and you look at the nail of your index fingertip, that would typically be about 1 degree in the human field of vision.
And then we have a question about how to buy these devices. We work with a number of retailers. Specifically, Pietro Orre was asking about the German-speaking markets. We do have we have a Schenker, which is one of our retailers in Germany, but you can also buy them directly from our store. And the same goes from the US-based. We have a few retailers in the US. I don't know the name of them, but Rave Computers are definitely stocking us, but you can also buy them straight. We are selling in 40 different countries, so through our web store you can go in and order them directly, and we are shipping the XR3 right now, so get your hands on a unique device. Go in and order. There's a lead time on a few weeks waiting time when you order, but yeah, we're ramping up production now, so it should go quite quick. And Tristan pasted the per case link here, so that's where you can order, get your hands on one of these unique mixed reality and VR headsets. Saccades tracking when it comes to eye tracking, 200 hertz. That's beyond me. I actually don't know. I know that these are the micro movements. So we do have a lot of traction in pilot training, and they are very interested in measuring the stress level, and that's why we have increased the eye tracker level from 100 hertz in the previous generation to 200 hertz. So I don't know what the exact levels for Saccades tracking is. I know that some have requested even higher numbers, but 200 hertz is it's twice as before. It's quite good. I don't know the exact answer on that, but 200 hertz I think is quite competitive. And there was a question about from Gulhermi Novak on if we are looking for specific project industries for the software partnership program. We are enterprise focused hardware, so we're looking at everything. Could be anything from maintenance to design to simulator and training and like emergency training scenarios. But we are expanding as well to this new generation, which is half the price from our previous generation. We are also looking into new ways like virtual monitors or remote working and collaboration. And so send in a proposal and we'll review it. We see better traction in some areas. We are not a mobile headset, so in that sense, there are some limitations when it comes to mobility because we are a tethered PC. So we also judge the cases based on what we believe where we see a best traction, so to say. And David Bibi asks if we're using Leap Motion for hand tracking, and yes, that's correct. It's Leap Motion has renamed into Ultra Leap, and that is something that we have integrated. It is, however, our own hardware for the Leap. Like it's our own hardware, but we run the Ultra Leap algorithm. So the SDK is very similar to the Ultra Leap's previous Leap Motion SDK, but there's some, it's not binary compatible, so you'd need to kind of upgrade to the Ultraleap's latest version of the software that runs. So any hardware, Zan Love asks if there's any hardware partnerships. Yes, we do have partnerships with a number of glove makers and body tracking suits, and also motion platforms for simulators. We don't have any specific partnerships with biometrics and neurofeedback, but I do know that iMotions provide services such as those. They are more like integrators. So if you look into the eye tracking and the research data community, you will see that there is certain companies doing these kind of integrations, and iMotions being one of them, that connects EEG and so on, measures that together with that. And is there any other question here?
There is one question about mixed reality lighting and reflections. Do you need to scan the room first, or is the environment data coming solely from the HMD cameras? And yes, confirming that this video with the silver spheres that we were showing, it is happening real time. So we are using the headset's front-facing cameras to scan the room, and it keeps updating as you look around. So it is real time.
And you can also use a scan, so you can scan the room with the headset, and that keeps the whole cube map. It's basically a cube map though, that comes into in the Unity scene in this case, and it's updated on a real-time basis on I think something like 60 hertz, and it's in HDR, so you can have create really good shadows, soft shadows with it. And now with the new version with the LiDAR, you'll also be able to get the depth map out of that. So you could create you can get the point cloud out of that. So the point cloud and the mesh that you're going to get out of this can be used for doing reflections as well.
A question about what role does audio play in your clients' experiences? Audio is an interesting part, and I think it's really part of making the immersive full mixed reality experience. We have received different kinds of requirements, and I guess one of the most demanding has been in a simulated training. And we have, at the moment, the Varjo headsets have a 3.5 millimeter headphone jack to connect any headsets and or headphones, and we have paid a specific attention to also the requirement from our customers that some of them want to use them with over-the-ear headphones, like the ones that I had to pitch in the beginning. So we had, when creating the ergonomics design for the wearing concept and the headband for our new headsets, this was a specific requirement that we paid attention to, making sure that the headband is slim enough so that you can also place your over-the-ear big headphones and use them together with the headset.
Then we have a question from Michael McNarma about developer kits. So we have SDKs, like software development kits from both like native one, and we're also providing an OpenXR kit that you can build experiences on our headset with OpenXR, and all the apps built on OpenXR works with our headset. And you can also run Unity or Unreal, and both of them are supported. When it comes to Unreal, it's the 426 version of the mainline, and when it comes to Unity, I think it's the many different versions. But yeah, so that you can build with Unity or Unreal, or you can do a native or OpenXR. I see a question from Per Roset. We have been using HoloLens 2 for industrial applications in maintenance and simulation. How is accuracy in comparison with Holo 2 headset for industrial applications? A good question. HoloLens is an optical see-through device, which is quite different from the visual video pass-through that we're using. So when it comes to like HoloLens is mobile, so you can bring it with you, so you can use it in a factory floor. Our headset is tethered, so in that sense, it's a little bit different. But when it comes to accuracy, when it comes to rendering quality and so, we do have an upper hand, I would say. We have a very high resolution of the render. You can see very detailed things as high resolution as your eye has, and we can also do it in mixed reality. So if you're comparing also the field of view, HoloLens has about this field of view, I would say, like 40 degree or something. Ours is full with 115 degrees field of view. So the mixed reality is the same field of view as the VR experience. So that makes a big difference when it comes to immersion. And also, of course, the transparency with HoloLens and optical see-through devices. They do have a transparency, so you always get bleed from the light behind of it. And whereas we are actually able to subtract light from the real world, like creating shadows. And thus the name actually, Varjo means shadow in Finnish. So the whole company was founded with the idea that you can actually subtract light and create shadows on the real world, which is unique with this approach.
I think that links well to the next question, which is about occlusion in real world and large scale. I guess when we compare this optical see-through and video pass-through solutions, this is one of those big differences that we can make. So when we are operating with the video signal, we can actually manage occlusions, and we can mix the real image and the virtual image as we want. And this allows specifically these kind of things as occluding virtual objects with real ones and the vice versa.
Yeah, then there's some question from Kenneth Mayfield about the sort of geosync and occlusion in real world. Yeah, geosyncing, I think that maybe that was the same comment here. But yeah, I think it's very interesting about this whole, like in mixed reality, to sync the virtual objects with the real world. And that is, I think, the next challenge for our industry, to really create this sync very perfectly. And I think we have mounted a LiDAR into our headset for that partly for that reason. So the LiDAR should be able to create a point cloud, and then you'd be able to kind of build apps that makes use of that and creates the space where you can fit your object in. And so there are also softwares focusing on specifically this geo-locking, which is a very interesting area, I would say. The resolution of the pass-through cameras, let me check that. I think I have, should be, I'll have to look in my cheat sheet here. Our cameras are 12, it's a 12 megapixel camera that you have. So with a 1.4 micron pixel sensor. So I would say that's, I think we crop it to some degree to, let me see, I'll have to look for the exact resolution, but it's a 12 megapixel camera. I hope that's enough data for you. Yeah, it's somewhere down here. Yeah, I cannot find the exact resolution of the actual stream that we're, yeah, it's 12, no, sorry. Yeah, I don't have that data actually right now.
Okay, we'll figure it out, and we can still add that information. There is a question about the 1-year subscription, and as I mentioned about the prices, the headset comes with a subscription that can be either 1, 2, or 3 years at a time. And what this subscription brings, it is the continuous license to Varjo software and business services. So with the headset, you get Varjo's software, and also the subscription unlocks our premium business support, which is available for our business-to-business customers. Anything else? question on wireless. I see this being asked a couple of times, and as Markus confirmed, we are currently tethered. So the headset requires quite some powerful computing, and this is our way of ensuring the low latency mixed reality, where we can always guarantee that the mixed reality content with real and virtual keeps in sync, and we can have all the processing power from the graphics processing as needed. Of course, we are looking at technical advancements all the time, but this is the fact today.
And then there is a question about multiple lights supported in the capacity of the real-time mixed reality lighting. Yeah, so when we're doing the scanning, you would be able to get different light sources in the room. So those would be reflecting. Of course, you could build more elaborate system with like creating a complete lighting model out of the cube map that we're creating. But right now it's a cube map that creates that is built in HDR, so you do get multiple lights in that. And so using those light levels from the cube map that you get shadows from different places. And then the follow-up on that we're building is also then with the LiDAR, with the point cloud model, but that's not on the level where we can do it yet. It's in experimental still, but that's pretty much it. But we're not actually doing the light modeling as in light sources in 3D, but it comes as an effect. The shadows comes as an effect of the cube map. Any examples about object recognition and then augmenting with virtual content like furniture? We don't have object recognition in our software. I do know that there are software libraries that provides this. We do have markers though. So if you look, you can create a QR code marker that you can print with your printer in black and white, and you can attach that to a physical object, and then we use that for tracking, so that when you move the physical object, then the virtual object is on top of that. You can, for example, use that on monitors and when you do masking. So typically in the cockpit setup or in a seat back in the car industry, you do have a setup, a physical hardware setup, and then you can attach a QR code to that setup, and then it will match. So when you're moving around or when you're switching the Steam system around, or like, then it will always align to that system. So, so it's a way to anchor physical objects to or virtual objects to the physical world. But we don't support 3D object recognition yet. Markus Solbaiti asks about the medical applications. Yes, this presentation was focused on the design, but we do have other, we have a lot of medical traction in medical, so medical training and like X-ray, for example. X-ray inspection can be done in 3D now, so there's software companies that we work closely with that provides services for scanning in CT scans into three-dimensional objects that you can then review in mixed reality or in VR. Yeah, there. Tristan posted a link here. Thanks, Tristan, about our examples of showcasing on medical. It's one of our verticals that we work very much with. And Artem is asking, any plans on going wireless? Nothing that I can talk about, unfortunately, but of course, 5G is around the corner, right? So, but no plans right now, nothing that we can talk about. But we have a big organization with R&D, and we're looking into all sort of different technologies. And then, of course, it's a different question when they get productized, and so that's a different question. There are limitations with the wireless systems right now. I think that's it.
Any more questions? Last questions, and then I think
it's really nice to hear from you guys. Really interesting questions, and I hope you get your hands on one of these devices. And if you're developing software, then please apply for the software partnership. Or if you are if there's any software that you would like to see, reach out to those software companies, and then our team will handle the integration and help them on board, and also share developer kits for these companies. And yeah, go in and grab one, order one now.
Thank you everybody for active participation. Really good questions. Nice chatting with you. And I want to wish you a really interesting summit and enjoy the sessions, and hope to speak with you soon again in the context of virtual and mixed reality.
Thank you so much.